Welcome back to Rishab's Engineering. Our question is maximum product subarray. Given an integer array nums, let's say this integer array is given, and find a subarray that has the largest product and return the product. Subarray is like you can take 2, 3 as your subarray, 3 maybe your subarray, or let's say 3 minus 2, 4 is your subarray, or maybe this whole integer array is your subarray. You have to choose that subarray which will give you the max product. So let's say let's write this example here. If I have this example, so in this case this is your subarray which will give you the max product, which is 6. You cannot take like 2 3 minus 2, or maybe 2 3 minus 2 and 4, or maybe this 4, because obviously 4 is less than this 6. So in this case you cannot take like this, right? So some of you might think like, let's take continuous positive integers, and maybe this is your answer 4, or maybe 2 3 is your subarray, which is your answer. And if you include 2 minus 2, so you are end up taking the negative value. But let's say if I have minus 1 in this array, you end up taking this whole array is your answer, because if there are even negative integers in your subarray, in your array, sorry, so you end up taking this whole array as your answer. So this is case 1. We can say this is case 1, and if I have even negative integers, I have to take this whole array as my answer, right? Let's take second example. Suppose this minus 2, 0 and minus 1. This is my example 2. In this case you cannot take like minus 2 and minus 1 as your subarray, because in this question it is already given that you have to take subarray which is contiguous. You have to take continuous values. If you want to take minus 2 and minus 1, you have to take 0 also. But and in this example 0 is your answer. If you multiply all these values from this array subarray, you end up taking 0, or might be you can take 0 as your subarray, which is your answer. And if you think for a solution, let's try to think first in a brute force way. What I will do here is like I will take all the possible subarray and keep tracing my max. Let's say this is my example, brute force. Let's say 2 3 minus 2 and 4. First of all, what I will do, let's say let's take this 2. Will 2 will be my max subarray or not? Let's take 2 3. Let's take 2 3 minus 2 as my subarray, or maybe this, and this is the iteration of I is equal to 0. I will take all the possible subarray which include 2, and in the next iteration of I will include 3, and let's say this could be my subarray, this or this, and in this way I will keep going, and I will end up taking all the possible subarrays which is contiguous, and keep tracing my max, right? So let's write the code for this approach. Let's say this is my max, main value. In the next iteration I have to take next value and keep trying all the possible subarrays from that value. Let's and keep tracing my max. So I have to trace max with the current product. So this is one, and my current product with this J will be this. And at the end I have to return this max. So I did some mistake here. So yes, it is accepted, but it is going to take a lot of time. I have to think for a better approach here. Let's say, let's think for an optimal approach. Optimal. Let's write this example, which is this 2, 3, this 2 and 4. Let's include some values in this subarray. So this is -1 and this is 50. So I have taken an example which include all negative values. Let's write all these negative values here. Right. Guys, it is very simple. Like if you take this -1 as your divider, the rest will be your even negative integers, and maybe your max lies here, max subarray. Or you can say, if I have this -1 as your divider, you end up taking even negative integer here, and maybe your max lies here, and this is it. uh, but there is a case like if you have 0 in between, so you end up taking 0, because if you are keep multiplying your value, if you have 0, your product will be 0. So it is like ocean in between two islands. So what I will do is like I will divide, like you can take this array is different and this array is different. This is your another array and this is your another, right? And keep applying this approach here and here, right? So what I will do is like, let's take prefix here. Prefix is equal to 1 in the starting, and suffix is equal to 1, and keep multiplying from this side. And for prefix I will keep multiplying from this side, and if I get 0 in between, I will say my prefix is 1, and if I have 0 I will say my suffix is 1, and keep multiplying. So in this way I will cover for this array and for this array also, and I will keep tracing my max. Let's write code for this question. Let's say I have prefix 1 and suffix is equal to 1, and my max is nothing but integer dot min value in the start, and what I will do, I will run this loop till length of this num array, and what I will say, my max is nothing but it is this max, or will be my prefix or suffix, right? Stick it in short form. And prefix is nothing but continuous product from the left direction, I, and suffix is nothing but continuous product from right side. It's total length minus 1 minus I. And if I get my prefix is 0, I will say please make my prefix 1. If I have suffix is 0, please have this suffix 1, and at the end please return max. Let's try to submit this code, and yes, it is accepted. If I talk about time complexity, for this my time complexity will be big of n because I am running only one loop, and space complexity will be big of 1. For the previous approach, I am running this loop 2 times, nested loops, so my time complexity will be big of n square. And if I talk about space complexity, my space complexity will be big of 1. So if you guys find this video helpful, please like, subscribe and share as much as you can. Thank you.